Hi guys, so here I am making this video over the intensely long section 2.2. We survived, we came out, and this is a video over the review of it, okay? Let's go ahead and graph this quadratic. Why not? We got nothing better to do, right? Okay, so let's go ahead and find the axis of symmetry. And I want you to follow along, and I want you to see what my expectations on the quiz is going to be and on the test, and that you show all your work, okay? And that's a very important IB thing. So negative 24 and 6, negative 4. So this implies that x equals negative 4. There is my axis of symmetry. My vertex, I am going to put my x in. And so that becomes 3, negative 4 squared, plus 24 times negative 4, plus 42. I believe this is negative 6, so implies that f of negative 4 equals negative 6, and therefore my vertex is negative 4, negative 6. Negative 4, negative 6 right here. Here is my axis of symmetry. Now, concavity is concave up, okay, since a equals 3, which is greater than 0. Now let's graph this. I'm going to utilize this a value right here to find that first, oh gosh, I'm sorry, the first set of points, okay? And so the way that I do that is from the vertex, I'm going to use that like slope and count 1, 2, 3 up and 1 to the right. And you know, this is up 3 and right 1. But of course I start the video off with a cough. Okay, so you know that there is going to be a reflection over the axis of symmetry. So we know that the other point's going to appear. Since it's a quadratic, we're also going to go up 3 and left 1. Okay, now, and that happens because our first set of points away from the vertex in a parent function is going to be positive 1 and positive 1. And this is not just like points. This is movement from the vertex. And it's going to be negative 1 and positive 1. So instead of like actual points, I want you to think about this as moving across or up and down the Cartesian coordinate. Now, when I multiply the y value, which this tells us to do because it's multiplying, well, the entire function, okay? What you find is from the vertex, now you're going to go right 1 and, or right 1 and then up 3. Here it's going to tell you go left 1 and go up 3. Okay? The next set of points that we have is 2 and then 4. And then negative 2 and then 4. If I multiply these by 3, now it tells you to go right 2 and up 12. This is going to be left 2 and up 12. Okay? So that is going to be right 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's going to reflect. And you see a very skinny so the kids that were told to memorize transformations, rather than understanding that it's kind of part of slope, and you're changing the way that you either go up or to the right or left based on your multiplier. The kids that remember it that way actually understand what dilations are and transformations are rather than memorization. Okay, so domain and range and set builder and interval notation. So domain is easy x such that x is an element of all real numbers. Okay, and then range, you can see that it is going to be the lowest point y such that y is going to be greater than or equal to -6. If I write that in interval notation, it's going to be -infinity to infinity. And if I write it as range, it's going to start at -6 and go to +infinity. Okay? Good job, guys. Okay, so we had a little controversy over this problem. Okay. And I told the 1A kids that this is actually from another school, Algebra 2 class. Okay. It wasn't really controversy. We just had a lot of fun. I did. Okay. So I asked the kids, hey, figure out how to do this. And then I forgot how to do it. And so you have some choices. You have standard form. You also have vertex form. Those are the only two forms that's really going to help you out. Okay. And so we had a student said, hey, use a standard form because it has this 9 here for the C. Okay. And then we tried, and we knew that it was A was 1. So we had 1x squared plus bx plus 9. Okay, and then we were trying to figure out what b would be. Okay, we can't reuse 0, 9. Okay, because then we still don't know what b is. If we put, that's not going to help us any to find any kind of equation. Okay, or I'm sorry. If we put 9 here, and if we put 0 for x's, it's going to eliminate the b. So it's not going to help us. Okay, so I'm thinking, and I'm like, okay, I forgot how to do it. And a student just says, you use the vertex form. Couldn't you use a vertex form? Because, okay, we know what A is. A is 1. And we can put in the 0, 9 value as x and y. So we can put it in for x and y. So we have x and y. We know that it didn't move up at all. So k is taken care of. That's going to be 0. So y is going to be 9. A is going to be 1. X is going to be 0. And k is going to be 0. Then we know what h is, don't we? And I went and shook Lacia's hand, and I just told her, thank you for saving the class. Okay, so that was pretty amazing. Okay, so that's my shout out. So let's go ahead and 0 minus h squared plus 0. And then 9 equals, this implies, okay, that is that negative h squared. I don't need to put the 0. Okay, and then that's h squared equals 9. So h is plus or minus 3. This implies. And that kind of little stuff where you didn't put the implies, that I'm not going to be a stickler for that right now. But just know, just get into the rhythm of doing that. Okay. So h equals plus or minus 3. Right? Okay. Now it gives you 2 options. If it moved right 3. If it moved right 3, then it would be here. But it's not. It moved left 3. So, therefore, my equation is y equals 1 x plus 3 squared, because it moved left 3. So that's my answer. Good job, Lacia. Next. Number 3. Whoa, it got stuck. Write the equation of the graph in the most appropriate form. Now, this one has a grid. Okay. I'm going to put it in vertex form. Y equals a x minus h squared plus k. And so y equals a, let's go ahead and fill this in, minus 3 squared. Okay. Now I need to figure out a. And you can put points in. You can put this point in. But I know I moved up 2 and right 1. So up 2 and right 1. So my a is going to be 2. Okay. That was easy. Next. Next. Okay, number 4. Find the equation of the asymptotes algebraically. So, the vertical asymptote, let's go ahead and write it right here. We need to set the denominator, okay, equal to 0. So x minus 1 equals 0, x equals 1, and that is my vertical asymptote. Okay, now the horizontal asymptote. The horizontal asymptote, notice that in order to find the vertical asymptote, we isolated y. Okay, and then we had x on the other side, on the right-hand side of the equation. And then we took that denominator and set it equal to 0. Okay, now to find the horizontal asymptote, we have to isolate x. Okay, so to isolate x, we have to solve for x. Okay, we're going to multiply both sides by x minus 1. So we have y times x minus 1. That'll cross this out and that out. So we get 3x minus 12. Distribute the y, xy minus y, 3x minus 12. Let's go ahead and group the x's together. So xy minus 3x equals y minus 12. Okay. And then I'm going to isolate x, or factor out x. divide both sides by y minus 3. So we get x equals y minus 12 over y minus 3. After we do that, we set the denominator equal to 0. So we get y minus 3 equals 0. And that implies that y equals 3. Okay, so my horizontal asymptote, let me go ahead, I'm going to write this over here. To find the vertical asymptote, you set denominator equal to 0. So the vertical asymptote is going to be x equals 1. And the horizontal asymptote is going to be y equals 3. Let's go ahead and graph that. Okay, before we can graph, we can just go ahead and answer our question about the domain and range, because there's only one asymptote for each, the domain and the range. So the domain x such that x cannot be 1. And to write it in integral notation, negative infinity to 1, 1 to positive infinity. Range is going to be y such that y cannot be 3. The range is going to be negative infinity to 3, 3 to positive infinity. Let's go ahead and graph our vertical asymptotes. And then horizontal asymptote. And then let's just put some points in, just some points. So I have 2. Let's put 2 in. That's going to be 6 minus 12 over 2 minus 1. So that's negative 6. Okay. And then and negative 6 right here. And I can put a 4 in. Let's try putting a 4 in. Times 4, that's going to give me 0. 4, 0, right there, right? 3 times 4 minus 12, that's going to give me 0. So our graph is going to look like something like that. I can put 6 in just to make it prettier. So I'm going to be, and then 6, 5, 18, 8, 2, 16, 6 over 5, which is 1.2. Is that 1.2? So 1.2, so 6, 1.2, something like that. Okay, let's put 0 in there. 0, negative 12, negative 12, negative 1, that's 12. 0 and 12. It's going to be off the charts right here. Let's put like a negative 2 in there. Negative 2 is going to be a negative 2, negative 6 minus 12, negative 2, negative 3, which gives me a negative 6, 18, negative 3, 368, 6. So negative 2, 1, 2, 3, 4, 5, 6. And that's good enough. 2 points. Okay. There you go. Good job. Next, we have a very similar problem. And so find Once again, the vertical asymptote is going to be x equals 3. Let's go ahead and solve for the horizontal asymptote. Let's go ahead and solve for x. So that's going to give me a 3x minus 9 times y equals -1. 3xy minus 9y equals -1. Oh, wait a second. We already know the horizontal asymptote. Horizontal asymptote is going to be y equals 0. Okay. Now, to find the domain and range in Step Builder, okay, so the domain is going to be x such that x cannot be 3. And then the range is going to be y such that y cannot be 0. Domain, interval notation, that's going to be -infinity to 3, u3 positive infinity. The range, -infinity to 0, u0 positive infinity. Go ahead and graph my right here, and y equals 0. Okay, let's go ahead and look for some points. Let's do maybe 4. Put a 4 in there. -1 over 4 times 12 minus 9. So -1 over 3. So -0.67. 4 -0.67 somewhere here. Okay, and then let's try maybe 8. Why not? -1 over 3/4. 24 minus 9. So that is -1 over 15. 15, and that comes out to be 0.06, 0.07. So that's going to be very, very close. You just tell right here. It's going to look like that. Like so. Okay. And then let's put in some more numbers. Let's put in a 2. 2, -1 over 2, 6 minus 9, -1 over -3. So it's going to be 0.67. So 2, 0.67. I have a feeling that this is going to get closer, so I could put a 0 in there if I wanted to. 0 and -1 over 9. 1 over 9, so what's 1 over 9? I don't know. 0.11. Like that. There we go. There we go. Okay. There's your graph. Good job, guys.